Hey guys, this is a re-upload of the question 3 that we were supposed to discuss, and I had uploaded a video as well, but it was after the upload that I found out that my mic was facing some issues. It was due to because my Mac was not upgraded to the latest OS for after like for a long time. So yeah, that was the reason my mic was acting up. Yeah, so sorry for that. We'll I think we'll just do the explanation again. Okay. Okay, so the question is that basically we are given a string s consisting of open and closed characters and an integer k. Now we want to remove all the k balanced strings from s, and after removal we want to return the final string. Okay, so let's say we take a look at this example. Um, let's say a string is like this, k equals to 1. Okay, let's refresh. Yeah, I think I'll just it's fine. Okay, k equals to 1. So this is balanced string, so we will remove this. Now we are left with this. This is also a balanced string, so we are now left with an empty string. So k equals to, let's say, 3 would denote that we want to remove all the strings which look like this. Okay, which are basically k open and k closed brackets. Okay, so that's what the example says, and that's what we want to do here. Okay, so let's take a look at how we want to like go about this problem. Okay, so we'll start with a good example. Okay, I think that would be easier for us to understand. Okay, let's say k equals to 3 and you are given a string like this. Let's put 3 here. Okay, let's put this guy. Okay, so k equals to 3 and we are given a string like this. So the variables that we want to maintain are, we'll maintain like I think four things, which one is will be open stack. This will represent the indices which have open braces. Okay, and similarly we'll have a closed stack which will represent the indices where the closed braces are located. And then we will have open counter, which is a array of how many, it is a prefix sum basically on the number of open brackets. And similarly we'll have a closed counter, which is a prefix sum on the number of closed brackets, but this is a kind of like modified prefix sums. Okay, additionally we will also have a variable p, which will denote my previous index on which the prefix sum of the current index should be calculated. Okay, so we'll go through how to do, like how to sync all this stuff. Okay, so let me have the indices 9, 10, 11, 12, 13. Okay, so open counter. Okay, so right now it's 1 and 0 because we have only one bracket, right? And your p is 0. Now open counter is 2, this is this, your current index is 1, and your p is changed to 1. Now open counter 3, p is closed counter is 0 because this is an open bracket, p is changed to 2. Now this is a closed bracket, right? So open counter will remain 3 but closed counter will increment to 1. Open, so your previous index is again now 3, right? And now here in this case your open counter is 3 again, but closed counter becomes 2 because this is also a closed bracket. And similarly here it's 3 and 3. Okay, so cool. You know what, I'll just remove this particular bracket just to make things a little bit more interesting. Okay, and I'll just select maybe and move this here. Yeah, and let's rename it 5, 6, 7, 8, 9, 10, 11, 12. Okay, so now here your open counter is 3, close counter is 2. Okay, this is the fourth index, so we'll update our p to 4. So here now you hit this case, right? So this is a break case where we want to reset. This is a case where we will reset it, reset our counts basically, because if you hit this case, then let's say no matter what brackets you have over here, this guy will not contribute, because and the following brackets that come after this will not contribute to the answer, right? So you might as well say that, oh, my open counter is 1 and closed counter is 0 here, because there is only one open bracket and we don't care what's happening in the previous state. We don't care what's happening in the previous indexes basically, okay? Because you cannot make a k balanced string. You cannot make a k balanced string by taking this into consideration, right? Since our previous was a closed bracket and now it's an open bracket, right? So the balance would not be maintained, right? So this is a reset case. So in case you hit a reset, you just reset it to 1 and 0, right? Because open is like 1 and close is 0, okay? Yeah. Then again we'll continue 1, 2, and your previous index is obviously 5. This is 0, previous index 6, 3, 0, 4, 0, okay? Four, 0, cool. Now this is again 4, 1, previous index should be at, I think you get to a 7, then 8, and then 9, okay? And then you got 4, 2, 4, 3, okay? Then you go to 10 and go to 11. Okay, sorry, we'll stay at 10, okay? Our previous index was 10, and using this 10's data, we calculated 11's data, okay? So now we hit this condition 4 and 3. So what does 4 and 3 mean? That means that our closed counter is exactly equal to k and our open counter is greater than equal to k. That means we have found a k balanced string, alright? This is the condition of having a k balanced string. And indeed we do have a k balanced string, this one. So if we remove this guy, this is a k balanced string, right? So we can just remove that guy. So how to do the removal? Okay, so remember we had a stack, right? So stack would represent the indices of open brackets. So you got open bracket index 1, 0, 1, and then you got 2, and then you got it at 5, 6, 7, and you got it at 8, right? Yeah. And you also have closed. So closed is there at 3, 4, and then you have it at 9, 10, and 11. Okay. So in case you see this condition, right? In case you hit this condition, we pop exactly k open and close indices from the stack, from both the stacks. So we'll pop 3 of them: 8, 11, 7, 10, 6, 9. Okay, so 8, 11, 7, 10, 6, 9. All of these guys will get popped. Let's pop them. Okay, so we are left with this stack, and we are left with, so basically we'll mark them as this, that these guys are removed. Okay, so we'll remove these. Okay, cool. So I'll just remove them like this. Cool. Yeah. So now if you see, my previous index is 5. So in order to calculate the count array for index 12, I need to go back to 5. So how do I get this 5, right? So your answer is you get this 5 from the stack. So if you take a close look at it, you see that it's the first element of the open stack, or it can be the first element of the closed stack. So now in this case, what you can do is P would be the maximum of open.top and close.top, okay, which in this case is 5. You reset this p to 5. So in case both the stacks are empty, right? If both of the stacks are empty, if like both the stacks are empty, then you can set p to the current index, right? If both the stacks are empty, then just set p to I, right? So in this case, our I is 11, right? We were standing at, I think, 11th index, which we removed. Okay. So, I mean, since it's empty, that means that it doesn't really matter, right? So we just set it to I, which is 11, and then we calculate the 12th index from there. Cool. We'll look at that example as well, okay, on why we want to set it to 11. Okay, so now what we'll do is we'll reset p to 5, okay, which will be the maximum of these two. So reset it to 5, and now p12, so now OC of 12 is equals to OC of 5, and close count of 12 is close count of 5 plus 1, because this is a closed bracket, right? So if it's a closed bracket, it's a closed bracket, then do this, or else it would be like OC of 12 is OC of 5 plus 1, right? Because you have to count the current open bracket, and CC of 12 is CC of 5 plus 0, right? So it's like CC of 5 only. Cool. So here what you would put is 1 and then a 1. So 1 comma 0, you follow this condition, you get 1 comma 1. Okay, and that's your final string basically. Okay, yeah, that's your final string, and your answer would look like this. This is your final answer. Let's take a look at one more example, okay, to make things one more clear. This time, let's take a look at this example. And 2, 3, 2, 3. Get one more here. Okay. Let's maintain OC and CC. So we got 1 0, 2 0, 3 0, 3 1, 3 2. Now you hit a reset, you hit a condition like this, you put it 1 0 again, 2 0, 3 0, 3 1, 3 2, 3 3. Okay, and now you hit this condition where open count is greater than or equal to 3 and close count is equal to 3 directly, right? So you hit this condition. So now we need to do the balancing, the rebalancing. We will remove this k balance string, right? And you would also have a stack. So let me have this indexes. So this is the open stack, this is your closed stack. Got 0, 1, 2, 5, 6, 7. Okay, and remember that we are standing at this index, at index number 10. And closed stack is it will be 3, 4, 8, 9 and 10. Okay, this is your closed stack. So we remove exactly k elements since we have hit this condition. Exactly 3 will pop, this guy pop, and this gets popped, and 5 and 8 also get popped. So basically we are removing this string entirely. Okay, so let's go ahead and remove that. Okay, and we're standing at index 10. So I'll remove these elements from the stack and remove these elements from the stack. Okay, so what would so now I will go to next index, which is 11. So when I am at 11, what is my P? My P is maximum of 4 and 2, which is 4. So now my P is 4, right? So in here, it's a closed bracket, right? So my OC of 11 would be same as OC of 4, which is my P, right? New P. 4 is basically this guy. This is my new P. And the counts are like 3 and 2, okay? And my CC of 11 would be CC of 4 plus 1. So this is nothing but OC of 4 is 3 and OC of CC of 4 is 2. Right? This is 2 plus 1, which is 3. So you again get a 3 and 3. You again get a 3 and 3 over here, right? And since you went to index 11, we will also push index 11 in the closed stack. Okay, we'll also push index 11 in closed stack. And now we hit this condition again. We hit this 3 and 3 condition again, right? This condition is true again. It's true again. So we want to again rebalance it. So how we'll do the rebalancing? We'll remove 2, remove 11, remove 1, remove 4, remove 0, remove 3. Okay? So essentially we are removing this entire string. So this, if you see, it's a k equals to 3, right? So in this case also it's a k balanced string because we have 3 open and 3 closed, right? So remove all of them and you get a empty string. Okay, that's your answer. So this is how your entire mechanics of the problem will work, right? This is how it is all coming together basically. Okay, and yeah, I mean, here we just stop the iteration and we'll just take a look at one more edge case where this case I was mentioning, right? Where if let's say both the stack get empty, then why are we setting P to I? That's a current element. Why are we doing that? So yeah, let's take a look quickly at that case as well. So let's say my let's say this is my string and let's say my k was 1. Okay, again OC and CC will do 0, 1, 2, 3. Okay, so OC is 0, sorry, it's 1 because we have 1 open. CC is 0, 2, my bad, 1 and 1. Okay, and we will also have a stack of open and close. Open we have pushed 0 and in close we have pushed 1. Okay, and our condition in this case would be CC count, like CC of I should be equal to 1 and OC of I should be greater than equal to 1, right? This is our condition in order to say that it's a k balanced string, right? So 1 is basically k, right? So OC of I should be k and CC of I should be k and OC of I should be greater than equal to k, right? So here we have hit this condition. We have hit this condition over here. So we'll just do a removal, okay, from the stack. So we'll remove this and remove this. So now we're basically saying we'll remove this string. Okay, cool. So we remove this string, and just to make things more interesting, I'll basically say, okay, let's say we have this guy like this. Okay, yeah, this 2, 3 and 4. We remove this string, and now I'm saying that my P was, I'll set my P to I. So I is currently 1, right? Because you're still standing at 1 only. So in this case, my P would be 1. Cool. So if my P is 1 and I've removed all these strings, right? So I've removed everything. So now I go to index 2, right? And index 2 will basically say that my OC of 2 would be equal to OC of 2 would be equal to OC of P, which is 1, and close count of 2 would be equal to close count of 1 plus 1, right? So it is basically, this is 1 and this will become 2. So I'll put a 1 and 2 over here. Okay, so basically we are continuing what we saw earlier, right? And in the other case, in here you can have two cases, right? Your k valence string will always end with a closed bracket, right? It will always end with a closed bracket. And here you can have two cases, either this or this case. So if you have this case, then it's a reset case where we'll reset it to 1 and 0. The count of OC and CC of 5 will reset to 1 and 0. But in this case, we are looking at this case, right, where it's a k balanced and the bracket after that is this guy. It's a closed bracket, basically. Okay. So here, like, if you can reset it as well, like you can reset to 1 and 0, or you can continue whatever you want. So it doesn't really matter, right? So 1 and 2, and then here, anyways, let's say here we have open bracket. So here the open bracket would become 1 and 0, right? Because it's a reset case, like this. It's a reset. So anyways, this, even if you set p to I, it's still disregarded at this stage. So it will get disregarded. Somewhere it will get disregarded, right? So doesn't matter if you set p2, even if you set p to I, our answer wouldn't change, right? That's what I'm trying to get at, because you would have a lot of closed brackets without open brackets, right? Because we popped everything from the stack, right? So here everything is removed, and at some point you would get open bracket where our things would get reset, right? Our things would essentially get reset. We would hit reset. So all of these are anyways invalid, and that's what we are trying to show over here, that by setting p equals to I, our answer doesn't change. Okay. So yeah, we'll continue with this problem. So 1 and 0, we reset it, and now we'll push, and also it's a closed bracket, so we'll push the 2 index over here, we'll push the 3 index in the open bracket, and now we went over here to 4. Okay, and my p is 3, by the way. In this case my p is 3. I'm like just updating the p, since it's just a normal p update from here, because you're not popping anything, right? So your p should be getting set to I every time you move forward. So now my open count is 1 and my close count is 1, right? So I've hit this condition again. I need to okay, I'll just put the close bracket 4 over here. Okay, so what we are saying is we will pop 3 and 4. Since we hit this condition, we'll remove this bracket 3 and 4, and yeah, that's it. So we are only left with this guy 2, and in this case our final answer would look like this. This is my final answer. Okay, yeah. So that's what I am doing here. I'll just go to the code now. We have a stack open and close. We have our counts as well, OCCC, and we'll just say if that index is removed or not. Okay, initially p is 0, our previous index is 0, and if our first element is open bracket, then OC of 0, like we have seen 1 open, we push the index of the open bracket to the stack, and similarly for close we do it. Now start iterating. Okay, if we see a closed, and if it's a reset case, your S of p is like a closed one, so it's a reset case like this, then just reset your counts, and else we do this. Your OC of I is OC of p plus 1, since it's open bracket at the at index, so plus 1 for that, and closed count remains the same as what we saw in the previous index. Okay, push the element index to the open stack, similarly do it for closed, right? And check for this condition, if it's a k balanced string or not. Okay, so if it's a k balanced string, then iterate k times on the stack and keep popping. Close.pop, open.pop. We are guaranteed to have k elements because our counts are in sync with the amount that we are pushing in the stack, right? That's why. So is removed of that index is true, is removed of open index is also true. Okay, and initialize p2 minus 1 because we need to reset the p, right? And this guy, basically the max thing that I was talking about, right? That's the thing that's happening over here. If open is not empty, then p is open.top, and if close is not empty, then take the maximum. Okay, and in the edge case that both the stacks are empty, then we can safely set p to I, as we saw in this edge case example, right? This example. And else is basically the case where this condition is not met, right? So this is like a normal condition that we saw over here, right? We was like resetting p until the condition is met. So p is just I, your previous index is just I, basically, right? So yeah, that's the code, and at the end we'll iterate on the whole string, and if that character is removed, we continue, else we append it to the answer and return the answer, right? Yeah, so you guys can do a dry run of it by yourself if you didn't understand the examples that I provided. I think I tried my best to explain it via a lot of examples, including the edge cases and handling, like showing the sync of these variables on why are they doing what they're supposed to do, right? In case you guys have doubts, please feel free to comment, and thank you for watching. Bye.